Hi friends, in second video you know all about SN curve and its practical application. Friends, in first video you know what is fatigue, its definition, and cyclic stress and its some formula. Now in second video we talking about SN curve. Friends, SN curve is also known as Wohler curve or stress life diagram. So S means amplitude. You see here sigma A equals to S, it is known as stress amplitude. So S is denoted as amplitude and N is the number of cycle. Friends, if you fatigue test done by altering the amplitude up to the failure of the component, fatigue test done by altering the amplitude up to the failure of the component or number of cycle. So here SN curve we draw for ferrous material as well as titanium alloy. So you see here this is a SN curve. This vertical axis shows S and this horizontal axis shows number of cycle denoted by N. Friends, if S stress is increases, then that particular component having less number of cycle. Friends, in this particular case, if stress concentration is high, then these part having their number of cycle is less. So in same scenario, if stress is decreases, then number of cycle will be increases. If stress decreases, number of cycle increases. You see here, if S2 is greater than S1, stress second is greater than stress first, then number of cycle is greater, N2 is greater than N1. This is only for understanding purpose. And at some particular limit, at some particular stress, the part having infinite number of cycle, and these limit of stress is known as fatigue limit, also known as endurance limit. Below this stress, the part having infinite number of cycle, and these stress limit is known as fatigue limit or endurance limit. So the definition of endurance limit is stress below which a material can bear or endure infinite number of cyclic loading without any failure. This is known as endurance limit. So for ferrous material we see some practical data. So friends, you see this material is made up of ferrous, and this material is under test condition, and this material having cyclic loading from here to here. It will be goes up and down. This is a cyclic loading, and this material is under test condition. For this material, for this component, we try to calculate endurance limit of this particular component, and this component having ultimate tensile stress sigma ut, and also it having 10,000 cycle. For particular sigma ut and 10,000 number of cycle, we try to find out endurance limit of that particular material, particular component. And if you want to find out sigma ut, then you take data sigma ut value from MTC, and if you don't know what is MTC, then you refer my video from playlists. So now friends, below 10,000 cycle it is known as low cycle fatigue, and above 10,000 cycle 10 to the power 4 is known as high cycle fatigue. Now we talking about SN curve for non-ferrous material. Non-ferrous material like aluminium, copper, plastic and its composites. So here friends, non-ferrous material having no fatigue limit. Here no fatigue limit is given. You see also as well here, S1 is greater than S2, then N2 is greater than N1, because if stress is increases, then number of cycle will be decreases. So for these materials The stress is specified, and as well number of cycle is given for that particular material, for non-ferrous material. You see here, this is a non-ferrous material, and this housing move from here to here. You see in the top of the video. This part also tested in lab and find out their hindrance limit for the particular SUT as well particular number of cycle.